Okay. All right. So what kind of questions do you guys have?
Page 204, section 4.8.
Page 204?
304.
304.
Yeah.
All right.
When you're done with this, are we going to start on a certain page in the book? Like
Yeah, section 5.2.
Number 30.
Let's see. So this is section 4.8, number 30. So 4.8 was all about solving equations that have fractions in them. And the beautiful thing about equations are they have two sides. So I'm allowed to do something to one side as long as I do the same thing to the other side. Very often what that translates into is if there's a part of an equation you don't like, you can do whatever would kill that thing as long as you do it to the other side. That's really cool. What that leads to, though, really quick side note, is the most common mistake I see, and I think I already said this before, but it bears repeating. If I say simplify this, should be that, but what I always get is somebody tells me, oh, just multiply by 7, 5 minus 3 is 2, yay! Easy. But of course, I mean, if it's just sitting there, if it's just an expression, you've multiplied it by 7, you've grown it, and nothing is there to balance that out. Whereas if I have this equals that, if I make that 7 times bigger and make that 7 times bigger, the equation is still true. So it's the two sides of the equation that allow me to kill fractions. But the minute I show students, hey, you can kill fractions, they all go, thank God. And then they kill every fraction they see. Right? You all become serial fraction killers. It's crazy.
You taught us.
I know. I just gotta rein that power in. It only goes so far. So number 30 says x over 5 minus 1 equals 7 over 5. So what's the very first thing you could do if you so desire? This is not the only way to solve this, but it's probably the easiest way to make this thing look better. What can you do right off the bat? Who had? Judy, yes?
I did add a 1 to get rid of the 1 and move the 1 to the other side. That's what I did.
Okay, you could do that. Nothing wrong with that.
Or you could change the 1 into 5 over 5.
That's what you'd have to do next. So, you could just go ahead and say, okay, let me add 1. Let me put it over here. Wow, that is dark. Add 1. Nothing wrong with that. You can just start solving the equation, keep the fractions in there. There's not a damn thing wrong with that, right? The equation, the process for solving an equation does not care what's in the equation. You start moving your numbers, you start moving your letters. I don't care if there's fractions in there. I don't care if there's decimals in there, which is in our future, right? I don't care what's in there. I just start doing that, if you want to. Yeah.
No, I'm just pointing at the board.
Okay. So what can I do on this side?
Common denominator.
Yeah, exactly. So I have to make this
5.
5. So I multiply it by
5.
5 on the top and bottom. So you get x over 5 equals 7 over 5 plus 5 over 5.
And you didn't do it to that side because it's already 5.
Exactly. It's already 5, so I don't need to multiply him by anything. So I get x over 5 equals 12 over 5. I love it.
That's it?
Well, no. How do you know it's not done? Because whenever I solve an equation, I know I'm done when I get x by itself. I got the equal sign the whole way through, but I know I'm done when I get x equals something. I don't have x. I got x over 5 equals something. So how do you kill that over 5?
Multiply by 5.
Exactly.
5.
And the really cool thing is, it dies there and it dies there. No need to make this 60. There's no need to make that 60 because the 5's die. That's what 60 divided by 5 is 12. But it's easier just to kill them and just see the 12. Now, let me immediately follow it up with the other way to do this. Right? The other way to do this is you'll like this. I think I'm going to try to stick with the second way of doing this because it's more generally good to know this other way. And what the hell do I mean by that? I mean not the way the book shows it. Don't multiply by the LCD. You could if you want to. If you like that way, great. But the way that actually works a little bit better in general is to make everything have the same denominator first. So what does this guy need?
5.
Yeah. And once you have everybody have the same denominator, you multiply both sides by it. So they all go away. You know, so and this problem is pretty simple. There's not a lot going on in it. So both of these ways are almost the same. Here I just multiply by 5 at the end. Here I'm going to multiply by 5 towards the beginning. Right? So if I multiply everything by 5, what happens?
They're gone.
5's cancel, 5's cancel, 5's cancel. So I get
X minus 5.
x minus 5 equals 7
So plus 5.
plus 5.
Plus 5.
X equals 12. Thank God, the same thing we got there.
So then I went to check it, I plugged it back in and I wrote out substituted the 12 over 5
Cool.
minus 1 equals 7 over 5.
So if we want to check, I want to start with the original equation. If I throw a 12 in, how do you do 12 fifths minus 1?
Excuse me. What I did was I broke it down and divided. I broke it down to 2 and 2/5, and then I minus the 1, so I came out with 1 and 2/5.
All right, I
I'm
like
sorry,
it. So
you know
this
what I mean?
is 2 and 2/5. And if you do that, it's 1 and 2/5.
Right.
And then how do you change that into an improper fraction? 5 times 1 plus 2, 7/5. Check.
So
It works. Cool. Nothing
that's
wrong
how
with
I
it.
did it. But
Now, obviously, checking these answers when you have fractions in your equation can get very disgusting if the equation has all kinds of different denominators running around and all this stuff. Checking it's going to be a little worse than it was in the equations before. They didn't have fractions in them. This is not too bad. The only fractions I already have in LCD, so checking it shouldn't be that difficult. So I like the way you went with that. You could have just made 1 5 over 5, right?
yeah,
12 minus 5 is 7.
yeah.
Yeah. But nothing wrong with bringing the mixed numbers in there. Why not? Okay. How do you feel about that? It's almost bad when there's more than one way to do something. So it's always when somebody mixes them. And when you mix two ways to do something, you end up with crap. It doesn't work. Right? So you got to pick a way you like and do it that way. Okay. Any other questions from homework? Yeah.
Number 18.
Been already the first one.
You done here? Oh, okay. So number 18 says, this is the 1/3 one, right? Like that. This one?
Yeah.
So here's the cool thing. Now, I want you to realize something. If I had 2x equals 6, what would you do?
Do the one.
Divide by 2. In fact, I said at one point, I said, whatever the hell is in front of the x, you just divide by it. Right? Because then you get x by itself. Don't worry about the b's and a's. Whatever the hell they are, you just divide that stuff. Right. So here, you could say, I want to divide by 1/3. What's wrong with, not really wrong, but what sucks about dividing by 1/3?
It's the same thing as multiplying.
Well, that's the good thing about it. The bad thing about it is it just looks disgusting as hell if I write this. That looks horrible, right? Well, what you're saying is, dividing by 1/3 is the same thing as doing what?
Multiplying.
Yeah, so if I multiply by 3, what happens?
The 3's go away.
And you end up with an x. That's exactly what I want. So it's a little more direct way of doing things. I mean, dividing by 1/3 would still work. 6 divided by 1/3 is 6 times 3. But if you just multiply by the denominator, that's the quickest way to kill your fraction. In this case, the top is 1, so you actually end up with 1x. That's all I want. And what do you got on the other side? Easy. Sweet.
What's going on right there with the 12/5 minus plus 5 question mark?
So it was, all right. So as we do things, you have to kind of follow along. But there was a 1 there. And of course, to do this, you have to get LCD. So I made it 1/1 times 5 times 5. 12 minus 5 is 7. That checks. And the other way that she wanted to do it, you could make it into a mixed number and do it the same way. Cool. Okay. Anything else from homework?
Making it into a mixed number seems like it would be more confusing, right?
Well, it depends. It all depends on what you see first. If you see a way to do it, you go ahead and do it that way, and then you worry later that there was a shortcut. Right? But sometimes if you see a certain way to do something, you just want to do it. You just want to do it that way and get it done. You don't want to sit there, is there a better way to do this? And now you're wasting time. Just do it the first way you think of, and it's still going to work. But you're right, in general, you do want to just go ahead. See how these are already improper? Changing the mixed numbers would make it difficult to compare them. But if you don't see that and the first thing you think is mixed number, go with it. Do it. You know, don't waste time trying to think, is there a better way to do this? Just do the first thing you think of. Okay.
So I'm really struggling with 4/8. And I think I had a case of what your syllabus said. So can we do number 3?
Yeah, sure. Now, I want to point something out. Now, so let's do several of these actually. So 3 we'll start with, and then we'll go on from there.
What page is that?
This is still section 4A.
304.
Yeah, 304. Let me put that one up on the board, and then let me put one next to it. I'll make up one. Another problem. Jeff's problem. I like it. Cool. Which one of these is almost solved already? Considering that my end, where do I always want to end up when I solve an equation? I want to end up with the letter by itself equals numbers. All right. So which one already has the letter almost entirely by itself already? The first one. So this is a good example of where I really don't want to multiply by the LCD. Because that's actually going to mess with it. I'm almost done. Y is almost by itself. All I have to do to get Y by itself is add that stuff out of the way. That's the stuff that's out of the way.
That's supposed to be -2.
Is it? Oh yeah. Okay. Thank you. So then, that's what to look for is if there's nothing on the variable, if the variable's already by itself, then just suck it up and just work with the numbers because you're almost there. There's no reason to multiply by the LCD and then make this not a Y anymore. It'd be 13Y. Then you're getting further away from being done. So if I just add 3/13, I'm done. So here I get Y equals, and of course it's really nice that they already have common denominator. What's negative 2/13 plus 3/13? 1/13. Cool. Now how would you do that one over there? There's 2 basic ways to do that one. And again, I can't do anything about the fact that there's multiple ways to do these problems. You really have to figure out which way works the best for you. And I always like to show the more general way first, and then I can talk about more specific things later. The most general way to handle a problem with fractions in it is to kill the fractions. But here's a really good example of where you don't want to do that. It'll still come out right. I mean, here, What happens if I do multiply by 13? What happens? Here I get 13y minus 3 equals negative 2. So then I would add 3, right? And then what's the last step? Divide by 13. So, I mean, it's not like if you do this, like you're going to completely mess yourself up. Right? You added one extra step on top of things. You guys with me? So it still works. If you just always kill the fractions, it'll still work. It'll always make a nice single line thing. See, there's no top and bottom. It's just everything's on the top. Right? But you want to look out for things that are almost done. Over here, there's two basic ways to do this. The first way is the more general way, the way that will always work. What would I multiply everything by? By 7. Right? That's the LCD. So if I multiply by 7, I'll get
X.
minus 21. 2x.
see that kicks ass. Right? I'm one step away from the answer now. What do I have to do?
Take the x.
Yeah, the only thing out of place is the x. So subtract the x. Done. Does anyone have a different way to do that second one? Let me write it over again. So that's done. It's fine, but there's a different way from the beginning.
You can do without the LCD, just
Yeah, I could. What's out of place?
x.
Yeah, the x over 7's out of place. There's the numbers. Here's all the x's. So I want to move minus x over 7. So here I get negative 3 equals, what's 2x minus 1x? 2x over 7 minus 1x over 7.
X over 7.
It's just x over 7, 11. And of course, what would the last step be there?
Multiply by 7.
Yeah, multiply by 7. I want to undo the division. So I multiply by 7, and I still end up with negative 21. So it really is just what way makes more sense, right? I'm trying to kind of lead you on a path that will help you when problems get more disgusting later. But for right now, it really matters just what makes more sense. So, let's see. Any other questions from homework? Yeah.
Number 27.
Oh yeah, that's gross. So this is the last kind. This is the one I've sort of been waiting to get a question about. That just kind of looks disgusting. But let's develop a shortcut for a problem that looks like this. Now I could actually do cross multiplying here. If I put the x up here, I could cross multiply. But let's not do this. A much better way to do this. What would I do to kill the 9?
You can divide, no, multiply by 9.
Yeah, if I multiply both sides by 9, that would kill the 9. How would I then kill the 5? I would divide by 5. Because the next step, if I kill the 9s, don't I have 5x? Equals blah, blah, blah. And then I would divide by 5. So the shortcut, when you have, all you have left, x is almost by itself, except for a coefficient. In fact, I don't know why I'm making such a big deal out of this. Here's one way to look at this is you multiply by 9 and divide by 5, and they both go away. Who knows what that's called? 9/5 versus 5/9. 9/5 is the reciprocal of 5/9. I love it. Because, of course, what do you do? I had this up here earlier. You want to solve that? What do you do?
2.
Divide by 2. So if I wanted to solve this, what would you do? Divide by 5/9. So dividing by 5/9 is the same thing as multiplying by 9/5. So So if I multiply by the reciprocal, I will kill the top and bottom of that fraction that's there. Because what do I always do when I have x almost by itself? What do I almost always do last? Divide by whatever the hell's there still. So I'm still dividing, just dividing by fractions is gross. We immediately change that into multiplying by reciprocal. Cool. So if I do 9/5 times both sides, here it totally dies. I get x. What happens over here?
Well, we can just reduce 3 and 19.
Yeah, the 18 and the 9.
2 and 2.
Yeah, 2 and 1. Now you could have done it this way too, but then you would have had to do it that way also. But anyway, you'll get there. So then on the top I'll get
Negative 3.
negative 3 over 10. I love it. Kick ass. So you guys try this one. So this is 27 part B. Oh, what you got, Jeff? I don't know. I like it. This is pretty much almost a you get it or you don't situation. You might have some trouble maybe with reducing it, I don't know, but what would you multiply both sides by?
12 over 7.
Yeah, the reciprocal is 7/12. Multiply by 12 over 7. So over this side, x is left alive. 7 goes into 14 twice. What goes into 12 and 27?
2.
3. 3 into 12 is 4?
And 9.
9. I like it. So what do you end up with?
8 over 9.
8 over 9. I love it. Just multiplying across. Does everybody see that?
Where did you divide 27 and 12?
The thing that goes into 12 and 27 is 3. Yeah. So that's the part I thought might give some people some pause. Because you look at 27 and 12, you're like, there's nothing common. But they both add up to be multiples of 3. So 3 goes into both of them. Cool. So how's that? Is that? Okay. So, I mean, this is a really good example of there's a different way to solve this kind of equation, but it's not different. It's just a shortcut of what we always do. We always divide by whatever the coefficient is. It's just when I have a fraction, the shortcut is multiply by the reciprocal. But so often I see teachers just teach that. And then students don't really see the connection. Why do we do something different here? It should be the same damn thing every time, and it is. I divide by it, but when I divide by a fraction, I multiply by its reciprocal. That's why it's the same thing. The process doesn't care. Okay. So let's get into some stuff in 5-2. So we're doing 5-2 through 5-4 today. Oh yeah. Let's see. So tell me, what is 2 plus 8? 10. That's good. What is 3 plus 4? 7. I like it. So what is 0.3 plus 0.4? 0.7. I mean, that kind of makes sense, right? It's the like terms. What is that really? How do you say that as a fraction? What is that?
3 over 10.
I love it. That's 3/10 plus 4/10 is, of course, 7/10. Now, what happens up here when I do 0.2 plus 0.8. This is where I get people telling me it's 0.10. It doesn't make any sense.
One.
Yeah. So what really happens here? 2 plus 8 is
0.
10, so you have the 0, carry the 1, and the decimal point is right there, right? So what's the most important thing when you're adding, subtracting decimals is that you line up the decimal point so that you're adding like terms. I can't add 2 tenths to 7 hundredths. So if I had this is the other kind of mistake I get. If I have exactly what I just said, if I said add 0.2 to 0.07, somebody somewhere always tells me that's somehow 0.9 or 0.09 or something.
0.27.
Yeah, so if you line it up, 0.2, 0.07, and you can put a 0 somewhere where there's a freaky blank spot, right? And then that makes it really easy, 0.27 when you add this. How we doing? What's up?
It's crazy.
Why is it crazy?
Why are you adding like 0? What's up?
You don't have to, but it's a really good idea. Right? I mean, it just makes it easier to look at instead of there being a blank space. Plus, when we go to subtract, I want there to be something there. So I can start borrowing and doing stuff. So if I add 0.2 minus 0.07, what the hell's there? There's an understood what there. 0. I can put as many zeros as I want to at the end of a decimal, right? We talked about that the other day. So this is going to be like that. So what would that be?
I'll leave 10 minus 7. You're going to borrow it? 0.2?
Good. So it'll be 0.13. Oh, that's cool. Right? You guys step by with me?
This is way better
Way better than what?
than the last subject,
All right.
4.8.
This is true. So what if I had something like this here? You guys try this.
Minus.
And obviously this is not me asking you just to type it in the calculator, so I like the fact that nobody's doing that. This is by hand stuff.
That's what I did before.
Do you want us to round?
Nope. If I don't say, you take it all the way out to whatever, so, but it's only going to be 3 places there, right? So if you line up your decimal spot, put 0 there if you want. Everything's lined up. And I just add. You get 9, 3, 1, 3, 4. I like it.
4,000.
Cool. All right, so I'm thinking you all should know this, but just to make it a little more explanatory as to why we have to do this, coming back to this, what is that as a fraction?
2 over 10. 7 over 7.
How do you make this into the same denominator? I can't add those because they don't have the same denominator. Yeah, multiply by 10.
1.
See, that was just like what we did. We had this, and what did I do? Added a 0. That was effectively the same thing as making the denominators the same. All right? And now it's real easy. 27 over 100. So that's 27 hundredths, which is exactly what we got. 27 hundredths. Right? It's in the hundredth spot, the second spot over. You guys see how all this comes together? So decimals are just specific fractions. They're the fractions that are based on our number system, based on multiples of 10. Right? So that's why we have a special way to write them. They fit into our number system. 1/5 does not fit because our number system is based on 10. But anything out of 10 fits. Out of 100, out of 1,000, it actually has a spot to go in. Does that make sense? Yeah.
Why is it in the hundred spot?
Where are we at?
You said 27 wasn't the hundred spot.
Oh, yeah. Because this is the ones. This would be the tens, right? So every time I take a step over, I divide by 10. Because this would be the hundredths. Divided by 10 is tens. Divided by 10 is ones. Divided by 10 is 1/10. So we call this the 10th spot. And then this is the 100th spot. There you go. So it's 27 out of 100 because it's in the 100th spot. Cool. So always make sure you got that THS on there if you mean decimal spots, right? Okay. So it's not too bad, right? Try this one out. Hopefully you gotta do the right thing.
5 0. Right? So,
You need as many zeros to provide a roof over all those numbers, right? Does it make sense? You have to have all those zeros up there above the numbers you have below. Because where's the decimal spot in the 1? Understood to be right after it, right? So how can I write this? If I put up here 1 point, I have to put the 0 point. So I have to put 0, 0, 0, 0, 0.
1 minus 0.
Now just to let you know, some of you guys should be just about done with this and you're enjoying it a lot. So I want to show you a shortcut after I've forced you to do the long way. So the long way is just you have to kind of like start here. Borrow, bam, borrow, bam, borrow, bam, borrow, bam, borrow, bam. Right? Good Lord.
It's a lot of borrowing.
You with me? So then you could do 0.0153. Cool. So here's the shortcut. Now go with me. This is kind of cool. And I know the immediate thing you can say is, Jeff, I love your shortcut, but I got a great shortcut. It's called a calculator, but I don't care.
Return it.
That is relaxing. 10 minus 2 is what? 8. Go with me. That's not very exciting. If I make 10 become 9, what do I have to make 2 become so I still get 8? 1. So, what does that have to do with anything? How does that relate to the problem we just did? Well, here's how it relates. Stay with me. If I have this ugly 1.00000 minus 0.98417, that's basically like 100,000 minus 98,417. If I say that, are you guys worried about my mental state?
Yes.
I mean, the nice thing with decimals is as long as you have them the same number of decimals, you can compare them like that. And when I see this and this, I say 20 and 19. Because then I can compare them directly. I've got the decimals set. So they are really like 20 and 19, because this is 20 out of 100, 19 out of 100, right? So what I can do now is I can make this go down by 1. That's 99999. If I make that go down by 1, what has to happen here so my answer is still right? Careful. It has to go down by 1 also. So how do you keep the distance between two things the same? If this guy comes down 1, I have to go down 1 to keep the distance the same, right? This is a shortcut I'm showing you right now, which is awesome. It's an awesome shortcut. Subtraction is the distance between two things. How do you keep the distance the same? Well, if he moves one way, he's got to move the same way to keep the distance the same. So if I make that one go down by 1, I have to make that one go down by 98416. Now that is a hell of a lot easier to do, right? What are you going to subtract those?
1,
5, 8, 3.
Same thing, right? You guys semi with me? So that's a beautiful thing about doing 1 minus some decimal. You can always make 1 become 0.9 or 0.99 or 0.999, as long as you make the other decimal go down by 1 at the end also. It's the same answer. It's a beautiful adjustment trick. Okay, all right.
That's pretty cool.
Thank you. And everybody else is like, calculator does it, no problem. Whatever. All right.
You haven't suggested, yeah.
Exactly. Blah, blah, blah. And there's nothing else besides that. This is just subtracting and adding.
Multiplying them.
Yeah, that's coming up. That's the next section. So let's kind of analyze this the same way we did addition and subtraction. We started off with writing some decimals. We wrote them as fractions just to see what's really going on. So if I had something like, and people always mess up, the wrong answer to this is 0.4. That's not right. So why the hell is that not right? Well, it should make sense. What's twice 0.2? What if you doubled 0.2? What should you get? So 2 times 0.2 should be 0.4, not 0.2 times 0.2. That can't be 0.4. Let's look at it a little better way. How do I write this as a fraction?
2 tenths.
Good. Careful. Tenths
2 tenths.
times 2 tenths would be. Careful.
420.
Come on now. Please don't make me cry.
No, 100.
Good.
100.
I'm multiplying, so I got to multiply across. Yeah, multiplying. So don't say I didn't say it. It's written right there. That means multiply. There's no symbol in the middle. Right? And how do you write 4 over 100 as a decimal?
35?
0.0.
You're thinking 1/4. Careful.
0.0.
Yeah, because you need it to be in the hundredths place, right? The second place out. How we doing? So in that first section, we talked about the basics of how to handle decimals, what the places are, how to translate from a fraction into a decimal and the other way around. So if I got 4 hundredths, I have to go out tenths, hundredths. That's exactly where I put that 4. So what's really going on here then? Every time I multiply by a decimal, there's some multiples of 10 on the bottom that's pushing me back. So there's a shortcut to this. And some of you guys should know this. When I multiply 0.2 times 0.2, 2 times 2 is 4. And then I just count how many total places are represented here. 1, 2. So then I go 1, 2. Done. That represents the factors of 10 that are kind of hidden in here. 10 times 10 is 100. I should go back twice. So every decimal spot I see is an over 10. So if I just collect them all, that'll be how much it would be at the end. So let's do a little more involved one. All right, take a minute and multiply that out, and then we'll figure out the decimal. The nice thing is the very first step is forget about the decimal. Just multiply that like it's 105 times 12. The last step is to worry about the decimal spots. So don't forget how to do this. It's just yeah, 0, carry the 1. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2. 0, 501. The great thing is when there's a 1, you just repeat the number.
1260.
So 1260. Now I just got to figure out where does that decimal place go. Well, how many total places do I have in the problem? 4. Good. 1, 2, 3, 4. So I got to go 1, 2, 3, 4. Bam. Because it would be over 10, over 1,000. Listen to me. Over 10, over 100, over 1,000, over 10,000.
Do you have to put a 0 in the front?
You don't have to, but it's a good idea because it really emphasizes that point, right?
You have a thought because you have to put in.
Yes, and it could drop off. All of a sudden, you go from a profit of 12 cents to a profit of $1,260, which sounds nice, but it ain't true if you just lost that decimal plot, right? Oh, and real quick, have any of you guys ever been down the hill, down Fletcher Parkway? There's like a bowling alley down there. Maybe you've even been in there. And I love it. And only a math teacher would do this. But up on the sign, they always have this sign. It's like 0.9 cents. And it just drives me crazy. Because 0.9 cents is less than 1 cent. It's like 0.9 cents per hour. And they really mean 90 cents per hour or $0.9 per hour, right? You guys with me?
Yes.
So whenever I see that, I'm like, I desperately want to be the dork that goes in and says, well, your sign says this, you false advertising, blah, blah, blah. But I just kind of go, oh shit, all right. But I'm curious if anybody even thinks about that. I'm like, it's just bad.
Nobody pays
Isn't it a sales technique that they use?
To get math people in there? Because people look at that normally, they don't even think there's a problem there, right? They see this and they just think 90 cents. But that says 0.90 cents. Less than a penny. Here's a penny, dude. You owe me change somehow. Good luck, right? Chop off a little piece of a penny and give it back to me. Because I'm only here for now. Anyway, all right.
Tell them that I told it's this grammar teacher.
What's that? Oh, man. I'll hold him to it. Let me see. Is there anything freaky here? Oh. So, the only freaky... The other thing that could happen would be if I had something like 0.04 times 10. You shouldn't have to do a lot of work for this. You should not have to set it up. You should not have to do the whole 0, 0, 0, 0, 4, 0, 0. No. You shouldn't have to do any of that. Our number system is based on 10. So let's really analyze this again. We always analyze this by rewriting it as a fraction to see what's really going on.
44.
What is 0.04 as a fraction?
4 over 100.
4 over 100. So if I multiply that by 10, what happens here?
10.
4
over 10. 40 over 10.
I'm not multiplying by 10 over 10. I'm multiplying by 10. So then I can cross reduce. So what do I get at the end?
0.2.
You have 4/10, which is 0.4. Right? So in the first spot. You with me? So when you multiply or divide by 10, all I'm really doing is moving my decimal spot around. When I multiply by 10, I get spots bigger. So if I took 0.003 times 100, every multiple of 10 is going to move me once. See how that moved once over? Bam. So when I multiply by 100, how many times am I going to move the decimal point? Once, twice. So the answer is 0.3. It's a beautiful shortcut. And again, the reason that works is what fraction is this? Tenths, hundredths, thousands. So it's 3 over 1,000 times 100. 2 zeros cancel, that's 3/10. But why do all that work? I got the shortcut. If I multiply by 1/10, I move it once. So 100 is 2 tens, I move it twice. So incredibly enough, how are we doing so far? Should not be a big revelation to a lot of us, but some of us might have forgotten this. So what if I had 0.05 divided by 1,000? If multiplying makes the number bigger, dividing, of course, makes the number smaller. So I'm just going to move my decimal how many times in which direction? Back. I'm going to make it smaller. If I move this way, it's making it bigger. So I'll move it back 1, how many times? 2, 3. So it'll be 0.00005. Whew. So multiplying and dividing by factors, multiples of 10 are stupid easy because our number system is based on 10. Of course it should be easy. I'm still going to get people that set this up like this and do all the work.
With the decimal point.
No need for that. You should just be able to move the decimal over. Yeah. So multiplying divided by 10 is just moving the decimal spot around. Cool. Okay, maybe.
What if it was a negative?
Oh, the beautiful thing about negatives and all this, if I make that negative, the answer is negative. Right? If I make that negative, the answer is negative. The negatives just kind of like hang out until the end. The same rules apply if I had two negatives. So if I had negative 0.0007 times 10, what would that be?
They don't cancel, so you'd still have to.
Yeah, the negative's still there. There's no other negative around to kill it.
0 point.
Where am I going to move the decimal? How many times? Which way? So it's going to be 0.007, and the negative is still there at 007. The anti-007.
Is equal to it.
Exactly. For the parallel
Doesn't
universe.
exist apparently.
And of course, if I would have made the 10 negative, they would have canceled then, right? So all the old rules are still there. So whenever we learn something new, it fits into everything we've learned before. Nothing else changes. We've just learned something new to fit in. So if I have two decimals that are negative, they're going to multiply to be positive. So if I had, you guys try this one. It's a point there, so be very careful with my points and my commas. And of course, some of you guys might be coming somewhere where the point and the comma have exactly the opposite meaning. I don't know if anybody's in that boat. So it's just an extra thing to get used to in the States. So when you multiply, you do not have to line the decimals up. There's absolutely no need for it. Here it just happens to line up. The ones we did earlier, they didn't line up. You don't care. It's only when you add, subtract. Addition, subtractions when you have to have like terms. So you have to have all your tenths, all your hundredths all together. So you do that by lining the decimal point up. Multiplication doesn't need like terms. Right? I could do x times x squared. That's x cubed. I can multiply things that aren't like. So I don't care where my decimal is. I just line my numbers up like I would normally. So here I just got to double this, and then I worry about the decimal sign. I worry about the SIGN sign. There's a positive, negative. So what do I get when I double this?
5,
Yeah, you get 8.
5,
5, 2,
Good. And it's
negative.
negative. Now how many places back do I have to go? 4. So 1, 2, 3. Put the point there. Put a 0 in there if you want to. Right. Leave your friends behind. So The second guy, the very first thing to realize is the sign. What happens to the signs?
Disappear.
Yeah, they cancel, so you have to worry about that at all now. And the beautiful thing is when I divide by some multiple of 10, if I just count how many zeros I see, 1, 2, 3, 4, that's exactly how many places I want to take that decimal. Well, which way am I going to go?
Down.
I've got to make it smaller. Good. So I would put 5971, put some zeros out here, and go, okay, now I got to go 1, 2, 3, 4, bam. I like it. And the negatives, of course, cancel, so it comes out positive. It should make sense. 5 divided by 10,000 is pretty damn small. In fact, 5 10,000s, how would you write 5 10,000s? As a decimal. Tenths, hundreds, thousands, 10,000s. Right? And look where we are with tenths, hundreds, thousands, 10,000. There you go, bam. It is basically 5 over 10,000 with extra crap at the end. Yes?
So if I vaguely remember, if we're, there was like some trick where you move the decimal to the left or to the right depending on the sign. Have you heard of that?
Scientific notation. That's in our future.
Okay.
We're not there yet. Yes, I don't know if you guys have ever heard of scientific notation. That's when you do something like 4.1 times 10 to the 8th.
Okay.
3.7 times 10 to the negative 11.
Okay.
That's later. That's not now. The negative or positive has nothing to do with the decimal. Right? Those are two different considerations. But you're thinking about scientific notation. Yeah.
Okay.
Okay. So multiplication, not that bad. It's the same as old multiplication, except there's just one extra step at the end. How many places back do I want to put my decimal? It's just one extra space beyond what we normally would do when we multiply. So how do you feel about that? Is that decent? Yeah.
So then we're always starting with a decimal at the end and we're just moving it according. Right?
Well, here the decimal was there,
Uh-huh.
right? So then I had to move it 1, 2, 3, 4 times. So 1,
Right.
2, 3, 4. Yeah.
Oh, okay. From where
But if
it's
it's
at.
if it's a whole number, then the decimal is understood to be at the end. Because, if I had 12, the decimal is understood to be there.
Right.
Good.
Okay.
Cool. All right. There's always weird teaching this because I'm sure some of you guys are really up on this. It's totally fine, and some of you guys are like, God, it's been forever. I forget this stuff. So it's really hard on you. I don't want to feel nobody should feel like they can't ask a question because they're afraid people around them are going to be like, oh, whatever. That's crap, right? So if you have a question about anything, ask it.
Are you making the all zeros like one spot when you're moving over? So 1, 2, 3, 4.
Exactly, because anytime I divide, here's 2.
Okay.
So what does 2 tenths look like? 0.2. See how the decimal moved back 1. So what does 2 hundredths look like? 0.02. The decimal moved back twice. So every division by 10 is moving the decimal back once. So then I could just count. How many tens do I have? 1, 2, 3, 4. Right, there's 4 tens in 10,000. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. That's 4 tens I just did. Right, to multiply it to be there. Cool. So every multiplication by 10 would make it that much bigger. 1 step over, 2 steps over. If you do it by 100.
So we, on top we had 5.971. That one, So the point moved from how you have it going over 1, 2, 3, 4 places.
Good. Because I divide it by 1, 2, 3, 4 tens. Every time I divide by 10, it goes back 1. So divide by 10, and then another 10, it goes back another 1.
So you count the number as 0.
Beautiful. That's the shortcut. Because every 0 is another 10. How many 10s in 10? 1. How many 10s in 100? 2. 10 times 10. 1,000. 3. And see how I can just count the zeros, and it tells me how many 10s are in the number. I like it. So that's why that shortcut works.
And when you go to the right,
That's when you multiply. You get, and of course, it kind of makes sense. I make a number smaller when I divide. I make a number bigger when I multiply. So it kind of tells you. I was always really bad. I still have to this day, just to admit this. Left and right. You know why I do this? Because this makes an L. So if somebody's giving me directions in the car, I'm like, okay, that's left. And it just is the way it is. I got too much other crap up there. So the left and right neurons are just fried or whatever. So I never memorized any of this with left and right. I always thought big, small. Right? When I divide, it gets small. That's whatever the hell that way is. When I multiply, I get big. It goes that way. You with me? And that's going to help you out a lot when we get to scientific notation. That's in our future. Somebody brought that up. That left and right thing kind of goes out the door, especially for me. Okay, let me see if there's anything else freaky in there. I don't think so. It's all pretty straightforward. Yep.
Why do you give us freaky stuff?
What's up?
Why do you have to give us
Because freaky stuff is out there.
So can we do number 7 on page 367?
Oh, yeah, the page that you assigned us.
Yeah.
We're not there yet. We haven't talked about dividing it.
Oh, sorry.
I thought we were supposed to do that.
So let's do this. Let's talk about dividing decimals, and then I'm going to give you guys a little assignment to do, and then we'll see where we are there. Some of you guys might remember how to handle something like this. That looks gross.
Disgusting.
What's really sucky about this is I don't want to think in my head 0.09 goes into... No, I don't want to think that way. So I'd rather work with 9.
Right.
Now, so some of you guys might know what to do here. I don't know if you know why you're allowed to do it. How do I adjust things so that I'm able to do this division better?
We just put 2 zeros.
Move this over twice.
Right.
But at the same time, I better
Move it over.
move this over twice.
So now you got room.
Right? Does that sound familiar?
Yes.
Let me take that away for a second.
So now it's gone.
If it doesn't sound familiar, fine, because I can show you right now. What does this thing look like as a ratio? Don't make a big deal out of this. What am I dividing what by what? What's on the top? Careful.
100.
What?
7
What am I dividing by?
0.
179.
0.09. Dividing by 0.09. And what am I dividing into? Okay. How can I make the bottom a whole number? Right now it's a decimal.
Multiply by 100.
Good. I multiply. Every time I multiply by 10, I move it over once, right? So if I multiply by 100, I better also do what? Multiply the top by 100. So if I do that, this goes over once, twice. This goes over once, twice. Now I get a nice whole number on the bottom, thank God. Because I can divide something by 9. I can't divide by 0.09 in my head, thank you very much. So that becomes the shortcut of however many times you have to move this to make it whole, you move this thing inside the same number of times. Because of that. It's a ratio. So if I multiply the top and bottom by 100, that's legal. So once, twice. So now I have 9 into 172940. Yeah. And then you just long divide there, right? You with me? I'm not going to give you a ton of these because you've already been tested on long division. So dividing decimals truly is just the same as long division. You just have to understand how that adjustment works at the beginning. So, I mean, to do this real quick. Good. 1, 2 would be 18 too much.
8, 2, 7.
Careful.
Oh, 9.
9. Good.
8, 1, 9,
2
2,
2, 18.
8, 1, 4, 1, 9, 5, 45, 5. What? Another 0?
Ah, see at the end. Oh, yeah. So you can add as many zeros as you need or want to. So I can continue adding zeros, so then I can still bring a zero down. But what interesting thing happens here?
It would keep going.
I mean, do you see how now I'm stuck in the same pattern? So how can you represent that very quickly?
Line over the 5.
I love it. See, what does that line over the 5 mean?
Infinity.
5s go on forever.
Yeah.
Right? Because I'm never at 5 times 9 is 45 minus 50 is 5 times 9 is 45, 50 minus 9 is, oh shit. So you put the line over there just to go, that's enough of that. It keeps going like that. Right? So that one's not too bad because when I moved the decimals over, there was no decimal really left until I had to pull it in there myself. But what if you have a problem like this here? So, in this kind of problem, where you put your number is so stupid important. It almost didn't matter on the ones that we didn't really involve decimals in, because you're going to come out with the right number. But here, you're going to put your decimal right above the decimal is. So you have to put the numbers you're using in the right place. So what I often get is, I often get somebody tell me to put a 5 there. The first off is 5 right? Well, 5 times 6 is 30, so it's right. What's wrong with it, though? It's the wrong place. Because now they're going to think it's 5 point something, which doesn't make a damn bit of sense. 5 times 6 is 30, but this is 3. So that's a problem. So organization is key. You have to put, 6 goes into 32, so I got to put the number there, over the 32. So then the decimal point ends up in the right place. And you can put a 0 there to make it stand out. And now you just keep going like normal. 5 times 6. Bring down the 1.
3. 8. 3. 6.
6, good.
6. 0.
So here is the kind of problem that you hope to God I say round it to something. So now we got to remember how to round. So let's say in here I say round to the 10,000ths place. So where am I at right now? Tenths, hundreds, thousands. So how many more times do I have to do this? Let's see. So 6 goes into 20. 3. So look what happens again. Don't I hit another? Right, it's going to be 3, 3, 3. So where's my 10,000 spot? Tenths, hundreds, thousands, 10,000s. So if I were to round it to that spot, what number do I look at? The next one over. So of course, how am I going to write this number then?
0.5362.
Careful. It's either 3 or 4, and because the next number is smaller than 5, I leave it at 3.
Where'd you get that 3? I mean, let's see how you get that.
Oh, 6 goes into 23 times. Do you see how now we're sort of in the same pattern kind of thing we were in before? 3 times 6 is 18. 20 minus 18 is 2. Bring the 0. 3 goes into 26. 6 goes into 23 times. It's going to keep on giving me 3s, 3s, 3s. But now I don't want a line over it because I say specifically round it to the spot. So watch out for that when they say round it to the 10th spot, 100th spot.
So we just dropped that last 3 because the 3 wasn't bigger than 5.
Exactly. If that would have been a 7, this would have been 0.5364. Cool. Let's see. So you guys try this one here. Well, let's see if you guys can handle this.
And just to confirm, when we're dividing, the top number goes off to the side and it goes into the bottom number, or the other way around?
Yeah, if I look at this, it's saying how many times does this go into this? So this
Okay.
is going to be the inside always.
Got it.
The bottom number on the outside going into this number. Now, if you set your division up a different way, I think I already asked this before. I think we're all able to do it this way, but if there's another way you like better, you could do it the other way. So we've seen some division like this before. I'm not just dividing by 6 or something. I'm dividing by 61. So what's the very first step? I want to make sure we're on the right track.
Move the decimal over 2 spots.
Yeah. So now I've got 61 into 209.4. And I know it's going to be negative, right? So 61 doesn't go into 2 or 20, but it does go into 209. And then you can kind of focus, I love it, 6 into 20. You can kind of approximate it by forgetting the last number. 6 into 20 3 times. Where's that 3 go?
Over the 9.
Over the 9. I love it. So placement is so key when you have these decimals. The spot has to be well known, or else you're going to be guessing and very often getting it wrong. So now I know the decimal's going to go right after that 3. I like it. Yeah, it's going to be, maybe I don't like it. 183. Yeah. Don't worry about that negative, by the way. Just you know it's going to be negative at the end.
I was in 4 times.
26.
Yeah, so you get 26.
Bring down the 4.
Bring down the 4. I love it. And do not worry about the decimal beyond getting it in the right spot. You don't have to bring it with you. You're just looking at the numbers as you do the division. The math picks it all up for you. It's kind of nice. As long as you get that in the right spot, everything else is good. So now you go 6 into 26. Maybe 4 will work. So you get
240.
244. So here I have to say something I didn't say. Let's say round to the hundredths. So let me make this a little clearer. If I say round to the hundredths, which spot do you actually have to go out to? Tenths, hundredths. I want to round to that number, but I can't round unless I know the next number over. So if I say round to the hundredths, you divide out to the thousands place, because you got to see if it's a 5, is it a 2, right? So I got to do 2 more of this. 60. So 6 into 20.
3 times?
180.
17.
17.
17.
What did you say? 17? Yeah. Bring the 0 down again.
2 times.
Is everybody cool with that? I mean, I could just keep putting zeros all day long. 6 into 17
2 times.
twice. Doesn't really matter what that is because I've got as far as I need to go, right? I'm at the 1,000 spot, so not getting around to the 100 spot. And that would just be what? I love it. That number is less than 5, so I leave it at 3. I don't take it up to 4. I like it. So if I don't say what place to round it to, please, dear God, come up and ask me. I didn't mean to, because I don't want anybody just going, it's going to stop sometime, because, oh, God. Right? He didn't say it's going to be somewhere. So no, don't do that to yourself, please. No extra credit. Oh, yeah, that's right. Okay. Where's that last thing? Oh, here's something, a little side note from earlier. Here's where things get really kind of freaky. So the biggest mistake I see is people do this, and they think it's something like 2.6, which is, you can't subtract 11.2 from 9.8. So when you have things that have different signs, you subtract the numbers, but the answer is going to be negative. So that's where understanding the rules of sign numbers comes in really handy. You subtract the bigger minus the smaller one, and then whichever one's the bigger one's got, whichever sign the bigger one's got, that's the sign you give to the answer. So it can't possibly be the 6. What is it actually going to be here?
1.4.
Gotta borrow.
12.0.
Yeah, so it's 4.
1.1.
Yeah, 1.4. Negative. So at the end there, negative 1.4. Like. So that's where the sign number rules come in handy. So you turn that bad boy around. So don't get freaky situations like this that you just can't do. Now, real quick. I mean, I think I showed you this before. I always get myself in trouble for this. But if you were to do this, 8 minus 2 is 6. I agree with you. That's 0.6. What's 9 minus 11?
Negative 2.
Negative 2. What's negative 2 plus 0.6? Now, see, that's, if you can't really do that really quickly, that's negative 1.4.
Negative 4.
So you actually get the same answer. You just have to be very creative. So creativity does belong in mathematics. It's like anything. You learn the basics of basketball. They teach you how to throw the ball to somebody else. They teach you how to shoot it. But then you make up your own stuff. Thank God, because that's what makes it interesting to watch. When guys put it into their legs and stuff. Same thing here. You learn the basics of mathematics, and then you go, can I be more creative with this? Is there other ways to put this stuff together that makes more sense to me? So that's like I was saying earlier. We need more and more people getting into mathematics so they help shape it in a more creative way. The more people that understand it, the more people can actually make it shape better. There's all kinds of little things you can do like this. But you can't do this if it doesn't make sense in the first place. Okay. I think this is as far as I want to make it. And I'm feeling a little bit rough. I don't know if you can tell. I'm feeling a little bit... So, I think that's where we're going to end. We just did 5, 2, 5, 3, 5, 4. And just to double check with you guys, I made a big point of this last time. There's a few of you who weren't here. Section 5, 2, 5, 3, 5, 4 homework is all on one page. Right? Or one... It's really 2 pages. Page 367 and 368. You don't do any homework out of those actual sections. Right? Unless you want extra practice. There's not a damn thing wrong with that. You can always do more than I assigned. Okay, that's plenty.
Are you sick?
Yeah. I'm not as bad as it was yesterday night.
That's it, 367, 368, right?
Yeah, it's on the homework sheet. Yeah.